Hey, welcome back everyone. So my name is Zach Vines, and what we're going to go over today is a pretty major part as you start to get towards the end of your second statistics class. And what we're dealing with here is an ANOVA table. So an ANOVA table deals with an F distribution, and for purposes of your class, oftentimes you're going to be directly told we're dealing with an F distribution, or we need to fill out an ANOVA table. So the purpose of this video is just to show you the relationship between the various cells in the table and how you can fill one out. And we'll even do an example at the very end of the video. And so just to kind of start off with, the layout of the table starts with a source. So these are basically the labels that you're going to attribute to each row right here, where the source deals with a treatment and an error. And another way that you'll see that written out sometimes is that the treatment will be known as a regression and the error is known as a residual. So it's just various terms to keep in mind. They mean the exact same thing, but depending on what class you're in and what maybe program you're using and the language they use in the output, you might see treatment as regression and error as residual and vice versa. So just make those synonymous for right now. But essentially we have these various columns like this, where we have our degrees of freedom, our sum of squares, our mean squares, and our F distribution, or our F value. So the point of all of this is to come up with our F value in terms of accepting or rejecting hypothesis and things like that. But what I want to show you in this video is how you could fill out an ANOVA table with very limited information. And not only do each of these cells have their own formulas, but you can rely on the relationship between the cells to come up with what the value is in that cell. So we'll go over both of those and then do a final example at the end that'll kind of wrap everything up nicely. So to start off with your degrees of freedom treatment, that is just going to be t minus 1, where t is going to be your number of treatments. So oftentimes in problems like this where we have an F distribution and we're dealing with an ANOVA table, the main example that I learned when I was first dealing with this was we had 3 different universities and we were trying to figure out if it mattered based on which university you went to, what your starting salary was for a certain major. So what we did is that we have these 3 different universities. We took into account we sampled a student that graduated from there, whatever their starting salary was. We wrote that down. It looks like we had 2 students that we sampled for UA, 3 for AU, and 4 for UAB. And so your number of treatments, you can basically think that as the number of columns and like what we're really testing against. Here we're testing between colleges. We're trying to see which college tends to, like, if it matters between them as far as your starting salary goes. And so t minus 1 will give you your degrees of freedom treatment, okay? As far as your degrees of freedom error is concerned, that's going to be n minus t. So t, that's the same t. It's the number of treatments. In the way this is set up, it would be the number of columns. As far as n is concerned, that's just the number in the sample, like the sample size. That's one of the most fundamental variables you have in statistics. And in this case, we have 3 treatments, so t would equal 3, but you can see that we actually sampled 1, 2, 3, 4, 5, 6, 7, 8, 9 different students to see what their starting salaries were. So here it would be 9 minus 3 would be your DF error. Now, with DF total, you can do n minus 1, which would just be your sample size, whatever that is, in this case 9, minus 1. But one thing I want you to keep in mind is that as we're going through this table, not only could you do these formulas to find out each of these values, but you can rely on the fact that if you take your degrees of freedom treatment or regression, whatever it's going to be called in the situation, degrees of freedom treatment plus your degrees of freedom error equals your degrees of freedom total. So let's say you didn't have the information about n or t, but what they gave you was your degrees of freedom treatment and your degrees of freedom error, then you could add those together to get your total. So you can rely on that instead of having to go into the data itself and find out what was n, what was t, and things like that. As far as your sum of squares goes, usually that's going to be a total plug figure. Oftentimes if you're dealing with Minitab or an Excel output with the analysis tool pack, it might provide this information to you. And if you have to do it by hand, that's a whole nother process to go through. But as far as kind of what we're focusing on this video and just relying on the relationships between them, you can essentially just plug those numbers in from whatever is provided. And again, rely on the fact that if you take your sum of squares treatment plus your sum of squares error, add those together, it gives you your sum of squares total. So if they only gave you certain information, you can just solve for x and find it out like that. So that brings us to the mean squares, where we have, and I just like to think about it like this. When you see SSTR divided by DFTR, you try to remember, okay, what's t, what's, it's a lot of variables to keep in mind. I just like to go, this number right here is the one to the left divided by the one to the left. So it is your SSTR, this number, divided by your DFTR, this number. And that gives you what this number is right here. And as far as your mean squared error is concerned, exact same thing. It's just going to be what's to the left divided by what's to the left. So if you already have that information, you'll be able to solve for this no problem. And finally, when you're dealing with your F value, that's going to simply be your MSTR, the top one that you just found, divided by your MSE, which is the bottom number. So just do top divided by bottom equals your F. So let's run through a quick example real quick, and I think it'll kind of help tie everything together. All right, so now we're going to work through this example, and you can see I've set up the exact same table that we had just a moment ago, but what I've done is that I've provided certain numbers and not provided other numbers. And so what we're going to do is just solve for the question marks just given what we have right here. So you can see we have 1, 2, 3, 4, 5 things that we're solving for, and we can actually do that even though we only have 1, 2, 3, 4 of the items out of the entire table. And so again, we're going to rely on the formulas within each of those cells, but also the relationship between them. And so let's kind of start with that. So we're going to start by trying to find our MSTR. So it's this number right here. Well, just a moment ago, we said that with the MS's, you just take what's to the left divided by what's to the left. So if we're just going to take 27 divided by 3, we know that our MSTR is going to be 9. So this number right here is going to be 9. So just rely on the formula. You already have the information and just plug it in, and you can keep going. And that's going to help us out in just a moment when we're dealing with F. So F, what we said before, is just to the left, take what's on the top divided by what's on the bottom, your MSTR divided by your MSE. Well, now that we know that our MSTR is 9 and our MSE is going to be 100, we know that our F value is going to be 0.09. Okay, so it's pretty simple to start off with. So we're just going to keep going through it. So now we're going to deal with let's do our SSE. So we know that this is just going to be a plug figure from some sort of calculation that we had based on what we just went over. However, we know that if you take your SS treatment, or really anything that has a total down here, add these two, and it's going to give you what your SS total is. So 27 plus what equals 50, that's going to be 23. So we have 23 right there now. Okay, and we just keep moving on. So now we're going to deal with our DFE, okay? So what we know about our DFE is that this 100 right here was what's to the left divided by what's to the left, okay? So as far as your DFE is concerned, we're going to have 100, because it's this number right here, equals what we just found out our SS error to be, or SSE, is going to be 23 divided by what we're looking for, so X. And at that point, you're just going to solve for that formula, and you end up getting that your DFE is going to be 0.23. It's just 23 divided by 100. Just do the algebra. X ends up being 0.23. And so we have 0.23 right here. And I want to point out, these numbers aren't necessarily realistic as far as what you might expect to see in an actual sample. It's more so just demonstrating how you can find these values given some of the ones that you have already. So the final thing that we have is our DF total, and what we know about that is if you just take your DF treatment and add your DF error to that, you end up with your DF total. So we know that we have 3 plus our DFE was 0.23, so our final answer on the DF total is going to be 3.23. So you can see, as long as you have the formulas down for each of those cells, and you can keep in mind that even though they each have their own formulas, you can rely on the fact that the treatment plus the error equals the total and find out that as well. So I hope this clears up the ANOVA table overview. And again, there's a lot that you can do as far as how you can accept or reject a hypothesis based off the F value. And this is really only a small subset of the scope of what you can do with an ANOVA table. But many times in my exams and my stats classes, I've seen this exact type of problem show up. So as long as you can keep those formulas down, rely on the relationships between them, you should be good to go. So I hope that helped.